Yeah, so up until this point, we've always assumed, or we've been given, a positive velocity, meaning that we're always walking in the same direction, to the right. What happens when we throw in a negative velocity? So I want you in your mind to imagine what a negative velocity graph would look like. Some people have different visions in their head right now, but a negative velocity graph is going to be, the velocity is going to be the y-axis, and it's going to have negative y values. So the whole graph is going to be underneath the y-axis when velocity is negative. So let's imagine right now that I'm going to walk to the east at 3 miles per hour for an hour and a half. That's a positive direction, so that means I have a positive velocity. But then I start turning around and I start walking west for a half an hour at 4 miles per hour. So that's going to be a negative velocity. And then finally I go ahead and I start going east again, 3 miles per hour for 1 hour. So we're going to find out our distance traveled. So we have to find our distance between 0 and 1.5. That's going to be 3 miles per hour times 1.5 hours, which is going to be 4.5 miles. That's the distance I'm walking to the right or east. I do the same thing, trying to figure out how far I'm walking west. And then finally, I'm going to walk east again. So I'm walking east for 4.5 miles. I'm walking west for 2 miles, and then I'm walking east for 3 miles again. So my total distance is going to be just the sum of those three numbers, but my displacement is going to be taking into account that I walked right, then left, and then right again. Ooh, there should be miles at the end of this, but it's 4.5 positive because I'm walking to the right, negative 2 because I'm walking to the left, and then positive 3 because I'm walking to the right. So our graph actually looks like this. This is what we were talking about at the beginning of the slide. When you have negative velocity, that means that you are walking in the negative direction. So the area under the curve here is going to be negative. So if you want to find total distance, what you're going to do is you're going to add these three areas together. And if you want to find displacement, what you're going to do is you're going to take the rectangle up top minus the rectangle underneath plus the rectangle on top. And then we can do the same thing with our, if we take the antiderivative of this, we get this curve right here. Notice the units have changed from miles per hour to miles. Here's my velocity curve over here. Here's my position curve over here. If I want to find the total distance, again, I need to go ahead and I need to add all of these distances, all of these changes in distance. Versus if I want to find displacement, I just find where I am and where I started, and I subtract the two. Cool. Next activity in class kick.